Good evening. Hope I'm audible and visible to everybody. Okay. We were taking a look at geometry, and today we'll be continuing with the mensuration part, that is area and volume. So, how much do you remember from the various formula of area and volume? Do you remember the basic fundamental of squares, cubes, cones, cylinders, spheres, and all that? You remember the basic formula for the surface area, perimeter, circumference, volume, and all that? Okay, so what I'll be doing is I'll quickly take you to the basic formula of the various shapes, right? Just to remind you of the basic formula, and then we will take a look at various problems, many of them which have actually been asked in the papers. So first few minutes I'll just quickly run you through the basic formula, and then we can take a look at the questions and how to apply these formulas. So remember, mensuration also has a lot of intersection with geometry, because to solve many of the problems of mensuration you will have to apply basic principles of geometry as well. So starting with the first one, we will take a look at area of various figures. So if I have a right angled triangle, let us say that I have a right angled triangle where I have a base and I have a height h, then the area of the triangle, a right angled triangle, is given by the formula half b into h, that is half of base multiplied by height, a very basic formula, right? And if it is not a right angled triangle, then for something which is not a right angled triangle, we will obviously have a base, but the height is always taken as the altitude from the opposite vertex. So this is the height. So again the formula here becomes half multiplied by base multiplied by height. And supposing we do not have the height, but supposing we are given the three sides, let us say that the length of the three sides are given as x, y and z, right? Let us say the three sides are x, y and z. Then first of all we calculate the semi perimeter, which is x plus y plus z divided by 2, and then the area can be given as root of s into s minus x into s minus y into s minus z. This is also known as Hero's formula for area of a triangle. So supposing you know the base and the height, then the direct application of half base into height. And if you do not know the height but you know the three sides, then the Hero's formula can be used to find out the area of a triangle. Then a simple square will have same length and breadth, so the area is given by the formula L square. Then for a rectangle with length L and breadth B, the area is given by the formula length into breadth. And supposing we have a parallelogram with L and B, but again we will need the perpendicular height, in this case h. So length into the perpendicular height will give you the area of the parallelogram. With me till here? Easy. Basic shapes. Okay. Now for a circle, the area is simply given by pi r square, where r is the radius, the length from the center to any one point. If that is the radius, then the area is given as pi r square, and the circumference or the perimeter, that is the border of the figure, is given by the formula 2 pi r, right? Okay. Now if I take a look at the area of certain three-dimensional figures, for example, this is a cube. So every face is a square and there are 6 faces. So area of one square is L square. So the total area for a cube will be given by 6L square. That is 6 times the area of the square making up its faces. 6 squares make up a face, so 6L square will be the entire area of the cube. Then a cuboid is an elongated cube. So if length, breadth and height is LBH, then the area is given by 2 times LB plus BH plus LH. So area of top and bottom plus area of front and back plus area of the two sides. So 6 rectangles. You add up their areas, you get the total area of a cuboid. Correct? Okay. Now, for a cylinder, if a cylinder is taken as a figure with a circle and height, then the base and the top will be a circle with radius r, and the height of the cylinder is h. So the curved surface area, that is, we are only looking at this curved surface area. That means if I consider it to be a hollow pipe, no top, no bottom, then the curved surface area is 2 pi RH, and the total surface area, which is nothing but the curved surface plus the top plus the bottom. So top and bottom both are circles with area pi r square. So total surface area is 2 pi RH plus 2 times pi r square. Okay. Then if I take a look at a cone, right, Joker's hat or ice cream cone, again we can consider it to have a radius r, the perpendicular height h, and the slant height is L, right? Right angle triangle. So obviously r square plus h square is equal to L square. Now the curved surface area, if I consider it to be hollow, no bottom, then the curved surface area is given by the formula pi r L, and total surface area, that is the curved surface area plus the area of the bottom, is equal to pi r L plus the bottom is a circle, so pi r square, right? Okay. Now this is pretty important because a lot of questions in the CAT often come with questions on spheres. So if a sphere, a three-dimensional shape, has radius equal to r, then remember the total surface area of a sphere is given by 4 pi r square, right? So the total surface area of a sphere is 4 times pi r square. Now volume of the same figures. So for a cube, L cube, because all three sides are same, so volume of a cube is L cube. For a cuboid, length into breadth into height, LBH, will give me the volume. Then for a cylinder with radius r and height h, pi r square h will give me the volume of a cylinder. And for a cone, 1/3 of a cylinder, so 1/3 of pi r square h, where r is the base and h is the vertical height. So this is the volume of a cylinder, volume of a cone, that is 1/3 the volume of a cylinder, right? And finally, for a sphere, the volume of a sphere with radius r is 4/3 pi r cube. So volume of a cylinder is given by 4/3, volume of a sphere is given by 4/3 pi r cube. Just basic formula to be kept in mind. Got all this formula? Okay. Now let's take a look at a few questions. The questions are very basic, but you have to apply the funda of both geometry and mensuration to be able to solve them. They may look complex, but give it a thought, they are pretty much solvable. Like the first one, it's an actual CAT question. A sphere of radius r is cut by a plane at a distance of h from its center, thereby breaking the sphere into two different pieces. So the cumulative surface area of these two pieces is 25% more than that of the sphere. Then you have to find the h, which is the distance where it was cut from the center. Give it some time, tell me if you are able to solve it. It's very important to first be able to understand what diagram will be made and then how to go ahead from there. So let's first understand the question. It says that there is a sphere of radius r. So assume that this is the sphere, right? So the radius is r. So this entire length is r. It is cut by a plane at a distance of h from the center. So if O is the center, let's assume that this plane is cut along this line, right? And it is cut at a distance of h from the center. So can I say that this particular distance here is equal to h, and if I join the line here, then this particular length is also r, as it is again the radius, right? Now if I put this particular thing as x, right, if I put this particular thing as x, then the first relation I can have is that x square plus h square is equal to r square, because this will form a 90-degree right angle triangle. Correct? Got that part? Okay, now comes the really interesting thing. When you cut a sphere and make two parts, the sphere technically is now, let us say, cut into two particular parts like this. So the increase in the surface of the area of the sphere will be along the base, right? So the part which I am marking in green, the two bases which have opened up, that will be the additional area, and both the opened areas will be perfect circles with the same radius, in this case the radius x. Correct? See, if I take a complete circle like this, and now I'm cutting it from here, so I opened it up into two, it was split into two circles like this. Now imagine a sphere is a 3D figure, it's a solid 3D ball. So when you cut a ball from the top and open it, the cut exposed surface is a perfect circle. Think of a watermelon, think of a full watermelon. If you cut the watermelon from the top and open it, the opened part is a complete circle. Okay, so the remaining portion, all this area was already there in the previous closed sphere as well. So the extra area that we are getting is nothing but this particular ऊपर के part का bottom and नीचे के part का top, which technically will be two circles of the same radius. You get that? The extra area will be two circles of the same radius. Okay, so can I say that the two circles of the same radius will have a total area of 2 times pi x square? So the new extra area is 2 times pi x square. What is this x? This x is nothing but a radius of that open circle, and that is 25% of the original sphere. So the original sphere will have the total surface area of 4 pi r square. So 25% of that is equal to the extra area. got this equation. Okay, so if I simplify this, the pi gets eliminated, 4 and 4 gets eliminated. So can I say 2x square is equal to r square? So can I now compare both these equations? The first equation was x square plus h square is r square, and now I have got 2 times x square is r square. Right? So can I say that h square is equal to r square minus x square, which is r square minus x square is r square divided by 2, which is r square divided by 2. So h will be equal to square root of r square divided by 2. So my answer should be equal to r divided by root 2. So the first option, r divided by root 2, is the value of h. Did you get that? Okay. Can we move on to the next question then? Shall we move on to the next question? Okay. Why I had got a diagram? Yeah. So the point is, the funda is very simple, but imagining what they're asking and getting the diagram right is half the trouble in questions of geometry and mensuration, right? Once you understand what they're saying, the calculation part is extremely simple, but just getting the concept right is important. So CAT does not have too much trouble with remembering formula. They won't ask any hard formula based questions. It will be very, very conceptual. Like the next one, look at the question. It's actually a very, very simple question and very conceptual. Formula wise, there's nothing great in this, but if you understand the concept and how to crack it, then you will get it. So it says cylindrical cans of cricket balls, so basically cylinders, are to be packed in a box. Each can has a radius of 7 centimeters and a height of 30 centimeters. Now the dimension of the box itself is length 76, breadth 46 and height 45 centimeters. What is the maximum number of cans that can fit in the box? It's a very, very conceptual question. And this is a very typical management type question where you have to maximize your resources. So operations theory, operations management में allocation of resources के problems typically ऐसे होते हैं. I'll give you some time, see if you can get the answer. Okay, so first what we need to understand is that when you're packing cricket balls, obviously you'll be packing them in an order. So first thing to take into consideration is that if the radius is 7 centimeters, then for a ball the diameter will be equal to 7 multiplied by 2, that is 14 centimeters. So one single ball is going to occupy a linear length of 14. That means if I put just one ball, it will occupy 14, two balls will occupy 28, three balls will occupy 42, four balls will occupy 56, five balls will occupy 70, and so on. In multiples of 14, the length will be occupied by the balls. Correct? So for one ball, two balls, three balls, four balls, five balls, and so on, these are the lengths required. Okay. And obviously the height of the can, this is the diameter. If I stack them like this, then the width will be a multiple of 14, and the height is always going to be 30 centimeters. So if I keep one can 30 centimeters, if I keep one can on top of the other can 60 centimeters, and so on and so forth. Correct? Okay, so now let's focus on the box. The box has length 76, breadth 46 and 45. So either you can consider that the base is of 76 by 45 centimeters, or the base is 76 by 46 centimeters, or the base is 45 by 46 centimeters. In which case, in the first case the height is 46, in the second case the height is 45, and in the third case the height is equal to 75. Correct? Okay, so now let us take the first case. In the first case, if I take 76 and 45 as the measures, then 45 means maximum 3 फिट हो सकते हैं हाइट वाइज, एंड लेंथ वाइज मैक्सिमम 5 फिट हो सकते हैं. सो 3 multiplied by 5, a maximum of 15 cans can be stacked. In the second one also 45 46 ज़्यादा फर्क नहीं पड़ता है. So 3 multiplied by 15 cans, 3 multiplied by 5, which is equal to 15 cans again can be stacked. And in the third one, because it is 45 by 46, so I can only stack 3 multiplied by 3, which is equal to 9 cans. Correct? Okay, now the height portion. Now in the first case 15 cans आ गए, तो उसके ऊपर तो 30 सेंटीमीटर हाइट से निकल गया, तो जो 16 सेंटीमीटर इज पेंडिंग उसमें आई कैनॉट स्टैक इट वर्टिकली. Same in the second, I cannot stack a second layer vertically. But in the third one, because the height is 75, I can stack 9 cans. On top of that, I can stack another 9 cans. That means in the third configuration, I can have a stack of 18 cans, because I can have 2 layers of 9 each. Okay, now 2 layers of 9 each in the third one can give me a total of 18 cans. In the first two, I cannot have 2 vertical layers. That means the first layer is 15 each. But what if I stack the cans horizontally on top of the first cans? Right? Because vertically, if I keep the can vertically, that means if I stack the can like this, then I need a height of 30 centimeters. But on top of it, if I stack the can like this, then I need a vertical height of only 14 centimeters extra. Correct? Stack diagonally. Now if I stack it diagonally, isn't it actually going to occupy more space and waste a lot of space? Diagonal stacking is maximum only in the horizontally. How much? See, the height here is 75. So if I stack it, okay, so that's what I'm saying. Now I'm going to consider in all of them. Okay, now in the first one, the height is 75. I've already stacked 2 layers of, I've got 18. Now how many more can you stack on top of that? If I take that, I have to stack now for 14 centimeters, right? My 2 of 60 are over, I've got 15 centimeters extra, and the diameter of one is only 14. So can I stack it like this? Yes. But 45 46 में I stack 1, I stack 2, I stack 3. So maximum I can stack 3. So I will get 21. Now similarly, in the other case, I have already fit 15. Now if I take a look at it horizontally, I can stack 6 of them, because 45 के अंदर 3, and because length is 70, 3 more, so 15 plus 6, again I can stack 21, and same funda I can stack. So maximum I can go with 21 in each case. So the maximum number of stacking which is possible is actually 21. You can't stack more than that, but 21 definitely you can stack. So कुछ vertical, कुछ horizontal. Correct? Yeah, dimension, they see, the common mistake we make is when they say length, breadth and height, we assume that only the horizontal should be length, the vertical should be height, and the other should be breadth. But where have they said you cannot twist and turn the boxes? And see, I'm not, even if I keep the box as it is, then while turning the box, I can talk about keeping it horizontally first and on top of that stacking vertically. This is for our understanding that I'm turning the boxes. But if I keep the box as it is, I can change the orientation of the cylinders inside. Do you get that? This is for our understanding. I've changed the orientation of the box. But I could have kept the box it is and kept the orientation of the cylinders. So in the third case, I'm starting with horizontal stacks and then putting vertical on top. So the orientation of the box remains the same in that case. Do you get this example? So there will be a wastage of lot of space, of course, but you can't do anything. So our first instinct is always to find out the volume of the box, volume of the cylinder, divide one by the other. But in real life, it only works when you are melting objects or it is a perfect fit. In these cases, you cannot have a perfect fit and you cannot change the dimension of the object. So that means you will have to work out how to maximize the space by changing the orientation of the objects. Correct? Okay. So let's try the next one then. Interesting. Basic area and geometry. It says PQRS is a square of side 2 centimeters and ST is 2 centimeters and PT is equal to RT. You have to find the area of the triangle PST. Take a look at this example. Interesting one actually. See, we calculated using the formula of a cuboid that we require 68 square centimeters as the total area of the object, which is a cuboid. And now for the papers, C and D cannot be the answer because their total area is anyway less. But for A says 68 and B says 72, and the question says that tearing is not allowed. That means you will have to fold the paper somewhere. And with exact 68 as the size, you will not be able to cover 68. You need a bit of more paper. So B would be the best one. Yes. So the line that the sheet of paper has to be used without tearing indicates that you will need slightly more paper, because when you bend paper or fold paper, that much extra paper will be wasted. So you cannot exactly cover it with 68 because that will be very precise. You need slightly more so that you can fold it. So the corner spaces will occupy some extra space. So you need to go with the size of the paper which is slightly larger. And hence the answer is B, not A in this case. Getting that? Okay. Try the next one now. So this one is slightly tricky because it takes a couple of different concepts together, but it is pretty interesting. Now it says the square PQRS has an equilateral triangle PTO inscribed as shown, and you have to find the ratio of triangle PQT to the triangle TRU. Right? Now before we start, let's mark a few things. Because it's a square, can I say that all the four sides of PQRS are same? So let's assume that PQ is X. That means PS is also X, SR is also X, and QT is also X. And if I let's take the measure of QT as equal to Y, then can I say TR is equal to X minus Y, because QR is X and QT is Y, so TR will be equal to X minus Y. And it is given that the entire thing is an equilateral triangle. So by rules of symmetry, we can say that the entire thing is very symmetrical. So SU will also be equal to y, and UR is also more or less equal to x minus y. Not more or less, it's exactly equal to x minus y. You get this portion so far. Okay, now let's start. It says you have to find the area of PQT to the area of TRU, right? So PQT, the top triangle, if I say, right, the area will be half of base into height, so half of x into y, and TRU, or this part TRU, is again half of base into height, and both base and height are x minus y, so x minus y square. So can I say as of now that PQT upon TRU, the half gets cancelled, is equal to x into y upon x minus y the whole square. Right? Okay. Now keep this aside for the moment as our first thing. Now let's start with the second part. In triangle PQT, can I say x square plus y square is equal to PT square? And in triangle TUR, I can say that UT square is equal to x minus y the whole square plus x minus y the whole square. So 2 times x minus y the whole square. In the two triangles I am applying Pythagoras' theorem, right? Now because it is known that PTU is an equilateral triangle, even this is same. So can I say x square plus y square is equal to 2 times x minus y the whole square? So now I simply expand this. So I get x square plus y square is 2 times x square plus 2 times y square minus 4 times xy. So I get, simplifying this, x square plus y square minus 4xy is equal to 0. And if I adjust the terms a bit, I can write this as x square plus y square minus 2xy is equal to 2xy. I am splitting the 4xy into minus 2xy minus 2xy and taking 1 on the other side. So then it becomes x minus y the whole square is equal to 2 times xy. Got it till here? Okay, so now done. Substitute the value of x minus y the whole square in our equation here. So I get xy, and the value of x minus y the whole square is 2xy. So xy gets cancelled. The ratio is simply 1 upon 2. Option D. Got this part? So it's actually through simple application of formula of area of triangle and Pythagoras' theorem, but you have to work it out a bit. Right. Let's take a look at another one then. This is pretty interesting. If you get it, you will get it easily. It's just simple application, but how do you do this? Okay, so actually there's a basic funda that we need to first understand, that just like the longest length within a square or rectangle will be a diagonal, similarly we also have diagonals for sided three dimensional figures like cubes or cuboids. For example, I could draw a cube or a cuboid, let us say like this, right? If I draw a cube like this and you want to fit the largest diagonal, then the diagonal from this end to this end will be the largest diagonal with it. Are you able to visualize it? Bottom left से opposite side में top, opposite top. So that will be the largest diagonal. And so if length, breadth and height are L, B and H, then the length of the diagonal, the largest one, will be root of L square plus B square plus H square. Just like length of the diagonal simple in a two-sided figure like a square or a rectangle is root of L square plus B square. So for a three-dimensional figure like a cube or a cuboid, root of L square plus B square plus H square will give you the largest diagonal. It is nothing but application of Pythagoras' theorem twice. You can prove it, but it's easier to remember. Do you get this fact? So this formula is for the length of the largest diagonal for a cube or a cuboid. Root of L square plus B square plus H square will give you the length of the largest diagonal in a cube or a cuboid, right? Okay. So now that we know the formula, there is a cube. I'm just drawing it in two dimension, of sides 5 centimeter and a suite of circle sphere is just inside. So first of all, can I say that the diameter of this particular thing, the diameter will be equal to the diameter of the sphere will be equal to the length of the entire thing. So that is equal to 5 centimeters, right? And cube is all the same. So can I say that I need to find out the distance between one of the vertices and the cube? The shortest distance will be this particular length, correct? So what I need to do is, from the entire diagonal of the cube, if I subtract the diagonal of the diameter of the sphere, I will get twice the length. So half of diagonal of the cube minus diameter of the sphere will give me the required distance, correct? See, I am going to draw it once again. I have, let us say, a square and a circle, right? If I want to calculate this particular distance, then can I say that the entire diagonal of the square minus the diameter of the sphere, so this portion is left, half of that is 1, so half of diagonal of the cube minus diameter of the sphere is the distance between the vertex and the sphere, right? So that's it. First let's calculate the diagonal of the cube. So that is equal to root of 5 square plus 5 square plus 5 square, that is root of 75. So that is equal to 5 root 3, and half of 5 root 3 minus 5, so that is 5 upon 2 into root 3 minus 1, so that is equal to 2.5 into root 3 minus 1, which is equal to the fourth option. So the important thing is knowing the formula for finding out the largest diagonal of a cube or a cuboid. Understood? (75√3). See, it is given that the cube is of 5 centimeters, so length, breadth and height each is equal to 5. So using the formula root of L square plus B square plus H square, we get root of 5 square plus 5 square plus 5 square, which is root of 25 plus 25 plus 25, which is root of 75. Or instead of putting it as root of 75, I could have written it as root of 25 times 3, so that is 5 root 3. Yes, got this one? Okay, let's take one last example for today then, and this is a very easy one. It looks a bit complex, but once you understand what the problem is, it hardly takes about a minute to solve. Anil grows tomatoes in his backyard, which is in the shape of a square. Each tomato takes 1 square centimeter in the backyard. This year he has been able to grow 131 more tomatoes than last year. So the shape of the backyard remains a square. How many tomatoes did Anil produce this year? Understanding the problem is the main thing. There's hardly anything to be done here. It says that each tomato takes 1 centimeter square space and the shape of the entire thing is a square. So can I say that the number of tomatoes is simply a perfect square number? The number of tomatoes has to be a perfect square because each tomato takes 1 square centimeter. So if there are n square tomatoes, then it can be arranged in the shape of n by n, making it a perfect square. So the number of tomatoes has to be a perfect square, correct? See, it says that Anil grows tomatoes in the backyard, which is in the shape of a square. So let's assume that is the shape of a square. Now each tomato takes 1 centimeter square. So each tomato, if it takes 1 centimeter square and the entire thing is a square, so if this let us say it's in the shape of a square, so either it can be 36 square centimeters or 64, a perfect square number. So that will be 6 by 6 or 8 by 8 or 10 by 10, correct? So the number of tomatoes has to be a perfect square, and if originally he grew a square tomatoes, then he grows 131 more and now it is b square. So the original square number plus 131 also has to be a new square number. So basically I need to find out two square numbers who are at a difference of 131 from each other, correct? So in this case, can I say b square minus a square is equal to 131? So b plus a into b minus a will be equal to 131. So 131 is a prime number. So the difference of b minus, so this can only be 131 multiplied by 1 is 131. I cannot get any other two factors for 131 because 131 is prime. So b plus a is 131 and b minus a is 1. So if b plus a is 131 and b minus a is equal to 1, then I get 2b is equal to 132. That means b is equal to 66. And if b is equal to 66, then b square is equal to 66 square, which will work out to be 4356. That is option C. Okay, but supposing it does not strike that 131 is a perfect square, or sorry, 131 is a prime number. Other way of doing it, I know that the answer is a perfect square, so I will check. I will find the square root of the options. So 4225, it is technically 65 square. 4096 is 64 square. 4356 is 66 square. If you can quickly find out the square root, I hope you know how to find out the square root of numbers. The quick method of finding out square root of numbers. Right? So all of them are perfect squares, and if you examine these two numbers, then 4225 plus 131 actually gives you 4356. So my new number is 4356. So using the options also I can work this out. Right? So either way, whichever strikes, you get it. You just need to be able to find out square root of numbers, or you should be able to work out that 131 is a prime number. Got this one? Sure. So we call it a day today. Any doubts you can always transmit over the app. Otherwise, we'll meet again in the next session. Chalo. Till then, good night.